بسم الله الرحمن الرحيم. أحبائي طلبة الصف الرابع في ثانوية المتميزين، إليكم المحاضرة التالية حول الفصل الثاني Chapter 2 Mechanical Properties of Material. External forces act on solid material, cause deformation in them, means that their shape changes, and this deformation depend on several factors include: number 1, the magnitude of the force act on the object. What does this mean? This means that, for example, the strong man can bend the iron bar and a little boy cannot do that. So the bigger force can make deformation more than less forces. Number 2, the dimension of material. You can cut a piece of paper into two parts by your hand, but you cannot cut your physics book because its dimension is larger than one paper. This is an example for the factor dimension of material. The third factor is the material that it's made of. Some materials are easy to deform them, and others are hard to deform them. The harder material is the diamond, cannot be deformed easily. Now let's go and answer the a question in the chapter questions. Question number 3. Question number 3. What are the factors that the amount and type of deformation occurs in the solid material? The answer of this question is: number 1, the magnitude of external force act on the object. Number 2, the dimensions of material. Number 3, the material that it's made of. Now we are going to study topic 2.1, elasticity theory and Hooke's law. Here we have a question. A steel wire is suspended from one end and a weight is attached on the other end. It slightly expands after a period of time, and when the weight is gone, the wire returns to its original length. Explain that. This is a question. Explain this statement. When we have a material, this material is consists of many molecules. These molecules are bound with each other by molecular forces. When we attach a weight on this material, the forces between molecules, we call them the molecular attraction forces. These molecular attraction forces will make this material to return to its original state. So the answer is, the explanation of that is: the wire that any weight is attached resists external force and that affects it strongly, and this force comes from the molecular attraction forces. Molecular attraction forces that appear as a result of the change in the shape or length of the object to restore the object to its original state. Now let's study the activity of elasticity concept to prove the Hooke's law. In this activity, the tools are a spring, equal weight of 0.1 Newton, iron hanger, graduated ruler, and a paper. Steps: arrange the tools as in the figure. We have a spring, indicator, several weights, a ruler. Next step, attach the spring vertically with the iron hanger and make a sign on the last ring on the paper behind the spring. Attach a weight of 0.1 Newton and record the increase in the spring length. When we attach this weight, we record this reading in the ruler. Attach another weight so that the total weight become 0.2 Newton. We see that the increase in the length of the spring is double of the previous increase. See this figure. We see when we increase the weight, the length of the spring will increase. Repeat the procedure using many weights and sequentially. We record the readings, then we plot these readings. We will have this figure 2.4, this graph between the forces, which is the weights, and the elongation, the stretching, delta L. We see it's a straight line. If we take the slope of this line, which is delta F by delta L, we will have many informations. The conclusion of this activity is the increase in the spring length is directly proportional with the tensile force within the limit of elasticity. This is the Hooke's law. This means that F is directly proportional with delta L. So F equal to K delta L. K is the proportionality constant, which is the spring elasticity constant. F is the tensile force caused stretching of the spring. Delta L, the amount of stretching. The K is spring elasticity constant, and its value represent the slope of the straight line, and it's measured in Newton per meter. So its value depends on changing the spring shape and the material it's made of. Now, what is elasticity? Elasticity is the resistance that an object shows to the force that change its shape or volume or length and return back to previous condition after the effectual is gone. So when the object returns to its original position, this is the elasticity. What is elasticity limits? Elasticity limits is the limits that the effective force exceed. If the effective force exceed, the object doesn't return as before. After that force is gone. Therefore, it's said that permanent deformation happened to the object. Now we have some questions First question, number 3. Hooke's law is applied to solid material in limits of C elasticity, in the limit of elasticity. The other question is number 9. The increase in the length or shape of an object out of elasticity limit is called, the answer is permanent deformation. Now question number 4. What is meant by elasticity constant of the spring, and what is the unit which we use to measure it, and on what does the magnitude, its magnitude depends on? The answer is elasticity constant is the constant that its value represent the slope of the straight line plotted between F and delta L, the force and the stretching. Its unit is Newton per meter. It depends on the spring shape and number 2, the material it's made of. Have a good day. Thank you. Goodbye.